let's compute an arc length parameter for a specific vector valued function describing a curve. So given that we have this function which parameterizes a curve, r of t equals 3 minus 3ti plus 4tj, let's find the arc length parameter for a starting value of t equals 0. So we're looking for the arc length from t equals 0 to any time. So to do that, we're going to use this formula. So if this is r of t, then r of u is 3 minus 3ui plus 4uj. R prime of u is negative 3i plus 4j. And then the magnitude of r prime is the square root of negative 3 squared plus 4 squared, which is just 5. So if we come over here and we want to find st, that's the integral from 0 to t, because we're starting at the value t equals 0 and we're moving to some arbitrary time. R prime of u du, so s of t is 0t 5 du, which is 5u from 0 to t, which is 5t minus 0. So what we find in this case is your arc length parameter is simply 5t. So what that tells me is that at any given time, I can take that time multiplied by 5, and that tells me how far I've gone along the curve. So for the next piece, we want to find the arc length for the curve defined by 0t2. So what's nice about this is instead of having to do this whole integral again, going from 0 to 2, now that I have this arc length parameter, I can simply find s of 2 equals 10. That's a really convenient way of dealing with getting arbitrary arc lengths. So if I had to find 10 different arc lengths, I don't have to take 10 integrals. And now we want to write r as a function of s. So if s is equal to 5t, then t is equal to s divided by 5. So what does that tell me? Then 3 minus 3ti plus 4tj, then I can rewrite that as 3 minus 3s over 5i plus 4s over 5j. And that would be my r of s. And that's how you would define that, so that the point on the line, or the vector value, is actually a function of how far along you've gone. So if I want to say, I want to find the point when I've gone, so like in this particular case, when I've gone 10 units of whatever, when I've gone 10 units along the line, when I've traveled that far, where am I at? Well, if I plug that in here, I would get 3 minus 30 over 5. So that's negative, that's 3 minus 6. So negative 3i plus 40 over 5. So negative 3i plus 8j. And so it would be no different than when we solved it as a function of t. If I plug 2 into the original function, that's 3 minus 6, which is negative 3, plus 8j. Now you might ask yourself, why in the world do I care about this? Why does that matter? Well, it matters for this reason. I have this r as a function of s. If I get r prime of s, so r is a function of s, then I end up with negative 3/5 I plus 4/5 j. And if I take the magnitude of r prime of s, what I end up with is 1. And what you find is that when a vector valued function is rewritten in terms of the arc length parameter, this magnitude is always 1. And again, that's a theoretical concept that we can use to leverage when we start talking about ideas like curvature.